Hello guys, welcome to Maths Learning Space. In this lecture, we will discuss about some basic concepts of systems of linear equations with the help of some easy examples, and we will discuss some notations which we will use in the subsequent lectures. So let us begin with the definition of a linear equation. So an equation that can be written in this form: a1 x1 plus a2 x2 plus and so on plus an xn is equal to b is called a linear equation in n variables. So here the terms a1, a2 and an and b, these are real numbers, and these a1, a2 and an are called as the coefficient, and x1, x2 and xn are called as the variables. So we can say that this is a system, this is a linear equation in n variables. So if we have an equation in two variables, so we will denote variables as x and y. If we have a linear equation in three variables, then we will write it down as x, y and z. If suppose we have a linear equation in 10 variables, for example, so we will write it down as x1, x2 and so on x10. So let me give you some easy example for a linear equation in two variables. So this is an example of a linear equation in two variables. So here variables are x and y, and the coefficients are 2 and 1. This is an example of a linear equation in four variables. So here if you see that in this equation the variables are x1, x2, x3 and x4. So if you notice that the coefficient a2 is 0. Why? Because the term x2 is not present in the equation. This is an example of an equation which is not linear. Why? Because if you see that if we have an equation is said to be linear if each variable involved in the equation have power only 1. So if you see that in this example x have power as half and y have a negative power, so this equation cannot be a linear equation. So solution is an equation is a value for each variable involved in the equation that makes the equation as a true statement. For example, if suppose we have an equation 4x minus 10y plus z is equal to 6, so we will say that x is equal to 3, y is equal to 1 and z is equal to 4 is a solution of this equation. Why? Because if you replace these values in this equation, we will get our true statement. You can see here 6 is equal to 6, that means this is a true statement. So for the equation 4x minus 10y plus z is equal to 6, x is equal to 3, y is equal to 1 and z is equal to 4 is a solution. Now let's move to the system of linear equation. So what is a system of linear equation? It is the collection of two or more linear equations involving the same variables. So that is called as a system of linear equations. For example, suppose if you have two equations in three variables x, y, z, so you can say that this is a system of linear equation in three variables. So let me give you some example of a system of linear equations in two variables. So we can say that this is a system of linear equation in two variables. This is another example of a linear system of linear equation in three variables. So in general, we say that we have a system of linear equations, m linear equations in n variables. It is given by this. So if you see here that we have m equations and n variables as x1, x2, x3 and so on xn. So this is the most general form of a system of linear equation. If we make the right hand side of that system of linear equation as 0, then that system of linear equation is said to be as homogeneous system of linear equations. Now let us discuss about the solution to system of linear equations. So it is the value for each variable that makes each equation as a true statement simultaneously. For example, if suppose we have a system of linear equations in two variables, so solution means the values of x and y such that these values satisfies or these values makes each equation involves in the system as a true statement. One thing you should remember that the some solutions are often written as an ordered tuples. And one more thing worthy to note, that a system of linear equation is said to be consistent if it has a solution, and if a system of linear equation has no solution, then we say that it is inconsistent. So let me give you an example of the solution of a system of linear equation. Suppose we have this system of linear equation, then we say that x is equal to 2 and y is equal to 1, or sometimes we will write it down as the ordered pair. So 2 1, that means the first value is for x and the second value is for y. So we say that this is a solution. So if we want to check it, so we can verify for each equation. So just put the value of x is equal to 2 and y is equal to 1 in this equation. So we will get a true statement. Similarly, for the second equation, just put x is equal to 2 and y is equal to 1. And you can see that again we get a true statement. So we can say that this is the solution of a system of linear equations. Now if we have a system of linear equations in three variables, suppose we have this system of linear equations, then its solution is for x is equal to 2, y is equal to 1 and z is equal to -1, or sometimes we can denote it as order triples 2, 1 and -1. That means the first one is for x, second one is for y and third one is for z. So we can again check that this represent the solution of this system of linear equation. So we can check for the first equation. If we put x is equal to 2, y is equal to 1 and z is equal to -1 in this equation, put these values, calculate it, and you will get the true statement. So that means first equation is satisfied, or it becomes a true statement. Similarly, for the second equation, just use these values, check it, and again you get a true statement. And for the remaining equation, put the value of x, y and z and see that again you get the same system, same result. That means it becomes a true statement. So this we can say that each equation is satisfied by the pair 2, 1 and -1. So it is the solution of the system of linear equations. I told you that what is a solution, but I did not discuss how we get that solution. So just first let me discuss the graphical solution. Suppose if we have a system of linear equations in two variables given as this, so we can obtain its solution graphically, because you see that you have two equations in two variables. So you can draw it as a line, and the point of intersection of these two lines will gives you the solution. This is one of the method to obtain the solution of a system of linear equations in two variables. So for example, for the first equation, if we draw it, Suppose this is the representation of the first line. I'm not saying that this is the exact draw, because this is the line, but just for the sake of understanding, I just draw it. And suppose the second line is denoted by this line here. So this point of intersection gives you the solution of the system of linear equations. Okay, so now for the possibilities of solutions, that means if we have a system of linear equations in two variables, then we will have three possible cases. First case is that no solution. So when we will obtain such equations representation, that means if you draw the two lines and these two lines comes out to be parallel, then we say that that system of linear equation has no solution. Why? Because they are not going to intersect anywhere. So that system has no solution if the equations represented as a parallel line. The second case is a unique solution or one solution if these two lines intersect at one point. Then we will have a unique solution because these two lines will not join anywhere else other than this point. And the third condition is the infinite solutions. This will happens only when the two lines coincide. Then we say that that system of linear equation has infinitely many solutions, because each point on this line will be a solution for that system of linear equation. So we have a question that for a general system of linear equations, how we can tell whether the system has a unique solution or has no solution or has infinitely many solutions. So these things we will discuss in our subsequent lectures. So if you like this video, so please share it and subscribe to our channel. Thank you so much.